postulates and diagrams. You've already seen 4 postulates. You should see them in your journals. The ruler postulate, the segment addition postulate, the protractor postulate, and the angle addition postulate. I know you've written them from the previous lessons. A rule in geometry, a rule that is accepted without proof is called a postulate. It's kind of like saying we're pretty sure these are true. They can also be called axioms. Rules that are proved are called theorems. So when you see postulate, they are pretty sure it's true, whereas theorems, they have proven. And that you can use these to solve different problems. So let's go over these ones you just got today. Postulate 5, through any 2 points there exists exactly 1 line. Postulate 6, a line contains at least 2 points. Postulate 7, if 2 lines intersect, then their intersection is exactly 1 point. 8, through any 3 non-collinear points there exists exactly 1 plane. 9, a plane contains at least 3 non-collinear points. 10, if 2 points lie on a plane, then the line containing them lies on the plane, in the plane, sorry. And 11, if 2 planes intersect, then their intersection is a line. So you're going to use these to answer why we know something is true. So let's look at example 1. I don't see an easy way for you to put these in your journal. I would at least write A in your journal. B is a little harder, so that's fine if you don't put that one in there. You can't take a picture as easy as I can. All right, so for A, we're going to look at this and then try not to look at the answers, guys. We're going to state which of those postulates that we just read is illustrated by the diagram. So let's look at A. If, what do we have here? 2 lines doing what? Intersecting. Then what changed in the second picture? There's a dot. So what postulate proves that? Yes, postulate 7. And you can write post. I'll let y'all be a little lazy, which is if 2 lines intersect, then their intersection is exactly 1 point. Any questions? Okay, for B, we have 2 planes also intersecting. And then what happens when we get to the second picture? They get a line. They form a line. So which postulate is that one talking about? Postulate 11. Makes sense, right? Yeah, it's okay if your drawings are funky. I am not an artist. That's why I'm cheating and taking pictures. The easiest way to draw is look at them separately, Gabe. So on this one, I draw this guy first. And then on this one, that's as good as it gets for me.
They do not look like that.
That's okay. I'm not grading you on your artistic skills. I'm grading you on your answer. All right. Good example 2. So we're going to use this diagram to write examples of postulate 9 and 10. So don't look in your book, look up here on the screen. Or look at your journal for what's postulate 9 say.
The plane contains at least 3 non-collinear.
Okay, so we're supposed to write using this diagram, so using points and things out of this diagram, we're supposed to say postulate 9. So this is postulate 9. You can put this in your journals. All right, a plane contains at least 3 non-collinear points. So what's the name of one of these planes that has 3 points in it? You just want to use plane P? Yeah, see this plane right here? So plane P contains how many?
3.
Non-collinear points. And what are 3 points that it contains?
B, A, C.
Yep, A, B, and C. Very good. Does that make sense? Pretty easy, right? All right, now we're going to do postulate 10. Go ahead and read postulate 10 to me.
If 2 points lie in the plane, the line containing them lies in the plane.
Very good. So which plane do we want to use on this one?
P.
P again, works for me. So we want to talk about 2 points. Which 2 points should we talk about?
B and A.
B and A. So we're going to say points, or point A and B, is probably the better way to say that, lie in which plane?
P.
Then you say, so line, which line is that line? What did they, I mean, you could call it line BA, but what's another, yeah, N. You see this over here in the corner? So line N also lies in plane P. Good. Any questions on how to do that? All right, I want to go over the little concept summary at the bottom. You can choose whether or not you want to write it in your journal. If it pretty much makes sense to you verbally, then I don't see the need for you to write it. Okay, you may choose whether or not you put this in there. So when you're looking at a diagram, let me get a marker here, I'm better with it. You can assume some things, and then there are some things you can't just assume by looking at it. So first, you can look at this. You see we have one plane, right? Plane P. And we can look at this and see that all points are coplanar. They're all lying on the plane. That we can agree on, right? You can see that angle AHB, so this angle, and BHD are a linear pair, right? Because they have an adjacent line and they lie on the same line. Then we have let me use a different color, AHF, so that's this one going this way, and BHD. What do those form? Vertical angles. They form that X. See it? And then we can assume that A, H, G, and D are collinear. They're all on the same line. This one going across here. And then we can assume that AD and BF intersect at H. That's right here. I've kind of drawn all over it. Okay? Things you can't just assume by looking at it. Let me use my little highlighter, see how this works. G, F, and E are collinear because look at where G's at. He's out here all by himself. If you look at it, they kind of look like they could lie on a line, but we can't assume because there's no line there. Line BF and CE intersect. These ones going this way. If they're parallel lines, you would think they won't ever intersect. But there's no label here telling us whether they are or are not parallel. So we don't know if they do intersect or don't intersect. We can't make any assumption on that. Angle BHA and BHA, that's going this way, and CJA going this way. We don't know for sure if they're congruent. If we knew those two lines that were cutting it were parallel, then we would know that they're congruent, but since we don't know that, we can't tell that for sure. And then the last one, AD is perpendicular to BF, or M, measure of angle, AHB is 90. Again, things you can look at and you think they're true, but since we're missing some labels on this, you can't assume it. Make sense? So what you might put in your journal if you don't want to write the whole thing is the page number, concept summary page. Let's see, that's page 89. So that way you know to go back and check on it if you need to. So let's look at example 3. This one you need to put in your journals for sure. We're going to sketch a diagram showing that line TV intersects PQ at point W so that TW is congruent to WV. All right, so what's the first thing we need to draw? I'm going to make my dot bigger. We need to draw a line called TV, right? So we have a line, put a dot on it, label it T, put another dot, label it V. Now we need to draw another line, and it's labeled PQ. Actually, it's a segment, isn't it? Look at the line above it. So it has endpoints of what? Very good, PQ. And it intersects at point what? So in the middle here is W. And the last thing we know is that segment TW is congruent to WV. So this segment is congruent to this segment. Now, my drawing is not perfect, but if you label it, then it is so. Good. Any questions on how we did that? You are going to have to draw a little bit today. Okay, let's look at perpendicular figures. We have one more example to do. Yeah, that was it. You just have to draw some stuff and label it. Pretty cool, right? All right, let's look at this. Perpendicular figure. A line is a line perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line on the plane that intersects. So you see how they've drawn a plane here. It looks a little skewed, but that's just because my book is folded right there. And it's telling you that this line going down the middle is perpendicular to each one of these 4 lines. If I could draw 4 little perpendicular things. It has to be perpendicular to each one of those for it to be perpendicular to the plane. Okay? So that's a rule, a definition you need to have in your journals. So let's look at example 4 now. Taking lots of pictures today. It's because I don't want to draw any of this. Which of the following statements cannot be assumed from the diagram? So looking at this diagram, let me see if I can just move this, yeah. Are A, B, and F collinear? So let's find A, B, and F. A, B, and F. Are they collinear? Does everybody agree? Collinear on the same line? Everybody agree with Gabe?
Yeah.
Yes. So that one we can assume is true. We're looking for what's not true. All right. E, B, and D. Where are E, B, and D? Are those collinear? No, E's all the way over by itself, isn't it? So we know that E, B, and D being this is not. Not assumed. We can't assume that E, B, and D are collinear. Okay, what about segment AB perpendicular to plane S? Where's AB? AB's right here. Let me erase some of my sketches here. Okay, AB, is that perpendicular to plane S? Well, let's look at it. What do we have right here? We have a right angle sign that's hitting plane S. So can we assume that AB is perpendicular to plane S?
Yeah.
Yes, you can. Just because of that nice little right angle sign right here. All right, what about CD? Is that perpendicular to plane T? So CD is going this way. Is there a perpendicular line?
No.
No, there's nothing saying that the blue plane is perpendicular to CD. So there's another thing. Segment CD, perpendicular to plane T. So that's another thing we cannot assume. All right, and the last one, AF, line AF intersects BC at point B. Okay, there's AF and BC. Does it intersect at point B? Yes, so we can assume that one. So out of that list, there was only two things that we cannot assume by the diagram. You should have written them down. Good? All right, this is the type of stuff you're going to be doing in the lesson. It's pretty much logic. Just look at it, use your rules that you wrote down to make sure you know exactly how to answer it. So you're doing numbers 3 through 23, and that's it.